All right, so yesterday, okay, in the podcast that you watched, one of the podcasts was on how to do a proper lab diagram using a picture taken with your phone through the microscope. Does everyone recall that? Okay, I have a similar thing that I did with my period 3s and 4s yesterday that will be posted in Google Classroom along with this assignment. It's not in there yet because I forgot to do it, but I'll put it in with this morning's podcast as well on how to do that lab drawing in case you've forgotten or you miss a step or whatever. Okay, so you can watch that one over again if you need to while putting your lab drawings or lab diagrams together. Okay, so today we're going to be looking at 4 different things under the microscope. Okay, we're going to start kind of big and then gets progressively smaller. All right, so essentially what the purpose of today's lab is to gain some experience with the microscope, using the microscope and focusing and things like that, but also to get an idea of how the microscope works. Okay, a microscope is a series of lenses. Okay, light travels through these lenses and its path is altered, okay, in such a way that the path of light essentially diverges and allows the image to look bigger in your eye. Okay, now there's going to be some evidence of that as you look through the microscope beyond the fact that you looked at small things and they looked bigger. That is not an unimportant piece of evidence. It is certainly evidence that the microscope is doing what I just described. But there's one other thing, okay? And that is that the microscope gives you a real image, okay? Yeah, so a real image has certain properties which you're going to notice with the first thing that we look at the microscope, or look at with the microscope. So the way to tell the properties essentially of an image is to look at something you know the properties of. Looking at an amoeba and going, does that look like it's supposed to look? I don't really know. I've never seen an amoeba before. Doesn't really help. So the first slide we're going to be doing is of a lowercase letter E. All right, so we're going to cut it out of a newspaper. There's a whole bunch of newspapers on the front table in there. So you'll cut out a small lowercase letter E. I know you can't possibly see that, but you can see there's a little piece of paper on this microscope slide. Okay. Now, this is also in the video that I made last week. Okay, I filmed all this stuff in 4K last week and it's posted with your thing already, all the observations. So, okay, I'm just gonna. I lost my letter E.
Oh, I see it. No way. I can see it. Right there.
Right by my foot. Yes, you can. I can't see it. See, I'm getting old.
Oh no, I lost it. I literally lost it. Right here. Okay.
Oh, perfect.
Okay, wait. Okay.
Awesome. Okay, thank you. Thanks for helping an old man out. Hey, Sonny, we're helping me. Okay, all right, so back to the letter E, which I'll now hold more securely on the microscope slide. Okay, so to make a wet mount of the letter E, it's quite simple. You cut out the letter E and don't lose it. Okay, put it on the microscope slide and make sure that it's right side up. Okay, we need it to be right side up so that we can see what the microscope in fact does to it when we look through the microscope. All right, so you're going to put it on the microscope slide and then you're going to take a drop of water, okay, with an eyedropper. There's a whole bunch of these on the front table as well, okay, and you're just going to add some water to the slide. If you add it from the side, okay, kind of like I'm doing here, not like dropping it onto the E will stay put. If you try and drop it onto the letter E, the E flips over. Okay, and it does that in my video as well, and then I had to turn it over manually. Okay, now it's going to move around a little bit. That's not a big deal. Okay, just try and get it back to vertical. Okay, and sometimes you just have to kind of move the water around a bit, and it'll sit vertical. Then you're going to take a plastic cover slip. They're in the box labeled plastic cover slips. We try and keep things easy. Okay, so you're going to take that. Okay, and you do need to be just a little bit careful with these. They're thin plastic, and the edges can be sharp if you're not careful. Okay, so you're going to take that thin plastic cover slip, and you're just going to, sometimes you use it to move the letter E back to vertical again. Okay, so you're going to take that, lay it at an angle. Whoop, I just dropped it because I'm clumsy. Lay it at an angle and just drop it on. Right, the water will keep it on there because water has certain special properties that we talked about in the last unit that might be important. Okay, so now see, oh, stays on. You want to turn it upside down. Oh, crazy. Okay, all right, so there you got your letter E. You're going to look at that one under the microscope. You only need to view it on the scanning power lens because if you make it any bigger, it doesn't all fit in the field of view. You can't see the whole thing. All right. The second thing you're going to look at is the amoeba. Okay. So just to give you an idea here, there's your letter E, right? So that's what the letter E should look like. Okay. All right. These are the three other things we're going to be looking at. The amoeba is this little purplish pink thing down here in the bottom left. All right. Not all amoebas have that shape. Every amoeba is different, like snowflakes. Okay, they're all different. The ones you're going to look at are stained slightly different than this. They may actually appear bluish green, okay, to purple, depending on which slides you get. Okay, but they generally are a blob with a nucleus in the middle. Okay, so shouldn't have too much trouble finding them. They're fairly large. You can actually see them with the naked eye on the slide. Okay, get them on scanning power, again on low power. Low power is probably the one that you'll see the best. Okay, then get them on high power. The problem on high power is that the amoeba, even though microscopic, still has depth, and it's deep enough that on high power, you can only focus on one part of it at a time. Okay, it's like if I'm standing here right now, if I'm looking at Jess, okay, everyone behind her is out of focus. Okay, but then if I look at Andrew, now everyone in front of Andrew and everyone behind Andrew is out of focus, right? So that's kind of what we're looking at. If you're looking at the amoeba, you can look at the front of it, the middle of it, and then the back of it, but you'll have to do it separately. Okay, everyone follow there? You'll actually probably get your best picture on the low power lens of the amoeba. The second thing we're going to look at is the paramecium. These are going to be dyed quite a bit differently than these ones are in this picture. We have about 3 different sets of slides. On 2 of the sets of slides, they're purple. On 1 set of slides, they're all different colors. I'm not sure how that happened. I think it has something to do with the gender thing going on. It's weird. Anyway, we won't talk about that right now. But yeah, they're going to be oblong like this. If you're really lucky, you'll actually see the cilia, which actually look kind of like little hairs that are at the top. Okay, or actually they're all around it. That's how it moves around. If you're really lucky, you'll see those. If not, don't worry about it. Okay, we're not too concerned about labeling the structures on these ones. Okay, just do your best. I'm more worried about the format of your lab diagrams, okay, and the quality of your picture on this one, so that when we start looking at something for real in the cell anatomy lab, that you're able to get good pictures and all that kind of stuff. Okay, and the last thing you're going to look at is the euglena, which oddly enough is the largest thing here, but is actually the smallest thing we're going to look at. Okay, when you first look at the euglena on scanning power, and sorry, you want to get the paramecium on high power, that's where you'll get your best view of it. Okay, the euglena on scanning power, you're barely going to see it. It's going to look like pale green flecks, okay, like little tiny slivers that you'll barely see, okay, that are like a bluish green. On low power, you'll start to see a little bit of their shape. Okay, they'll look still smaller than what the paramecium looked like on scanning power, but they're similar in shape. Okay, on high power, they'll still be quite small, but you'll be able to see some structures at least. If you're very lucky, you'll be able to see their flagellum. Okay, the euglena is kind of a strange organism. It's photosynthetic and it can move. Yeah. Okay, so they're pretty cool in that they can, you know, if they get hungry, they just got to swim into the light. And they'll feel better. Yeah. Okay. So those are the other things we're going to be looking at. You're going to need to make a lab diagram of all 4 things. Okay. So one diagram of the letter E as it appears under the microscope. Okay. Draw it exactly like your picture. Don't draw it. Do it exactly like your picture is. Don't try and do any editing with the picture. Yes. On the letter E, the labels I'm concerned with would be outside, inside, ink dots, if you can see them, paper, fiber, whatever you can see. I mean, get creative. Again, I'm not worried about whether you label the structures correctly in this lab, just whether you do the diagram correctly. Okay, so make sure your name and date's top right corner, titles are underneath, magnification, size. Yep. Okay. They're going to go in your observations. So you're gonna put them in there, right? They're one page each. So make sure that you make them big enough that they take up a full page in the lab report, nice and big, like we talked about yesterday. Don't worry about it. Yeah, I'm not worried about it. That's where your lab diagrams are going to go. Okay, Calvin. Google Drawings, like I showed yesterday. Yeah. Okay. Check. I just said that. No, I don't repeat myself. Okay. All right, so let's go back here to the stuff you're going to need for your lab report. So hopefully you've got that open here. Okay, a little bit of tips and hints here. So the problem, how does the microscope allow us to see tiny specimens? So we're talking about how does a microscope work here? And right at the very beginning, I give you a little blurb about bending of light and lenses and things like that. Okay, for the design, we got a manipulated, responding, controlled variables. Okay, are we looking at different things? Okay, one of our variables is about things we make different. Hint, hint. Okay. Responding variable. Okay. That one I'm going to give you. The responding variable is the appearance of the specimens. We're trying to find out what a microscope does to things. The appearance of the specimens is what's going to help us do that. Okay. Controlled variables. Three things that remain the same throughout the entire lab. Okay. Environmental conditions are not really all that important for what we're doing today. A microscope works whether it's hot or cold. Okay, I've never tried one in the rain, but you know, environmental conditions are really not all that important, so they really shouldn't appear with your controlled variables this time. They do affect chemical stuff, but not so much when you're looking through a microscope at stuff that's been dead for who knows how long and preserved on the slide. All right, so I would suggest anything about your technique or the equipment would be the same each time you look at a new organism. All right, so I would be looking at those kinds of things and how they might affect the experiment. Because remember, we need to identify and explain manipulated, responding, and 3 controlled. And remember, we need to explain each controlled variable separately. Okay, that explanation needs to include how is it being controlled? What effect would it have if you didn't? Okay, for example, I'm not looking at the letter E with a light microscope and the amoeba with an electron microscope. Hardly a fair comparison of how a light microscope would work. Okay, all right. For our hypothesis, okay, if, and then. This lab is about how a microscope works. What should be in the if part? How a microscope works. Okay, that's what should be in the if part. Okay. Okay, and that's a light microscope, not an electron microscope. Okay, so how a light microscope works. Okay, the and part describes the experiment, same as always. Okay, the then part. Okay, what's the evidence we're going to have? Okay, we just said that our responding variables, the appearance of the specimens, that's usually what you talk about in the then part is what you're going to get as results, right? So in the then part, how is what you're going to see tell you how a microscope works? Okay, your observations marks, that's your lab drawings. Okay, it's also partially your analysis, but mostly it's just your observations. Okay, and then for the analysis here, using what you saw under the microscope, the size, the orientation, and the general characteristics, explain what you think happened to enlarge the specimens. I would say specifically the letter E here. Okay, you probably will talk about the letter E quite a bit more in your answer for this question because it's the only one you'll know about the orientation of versus what it looks like under the microscope and what it looks like when it's not under the microscope. Okay, comparing those two things. So most of this explanation will be about the letter E. Not to say you can't say that, well, the amoeba looks bigger. Yeah, you can, but the letter E is going to be more important in the answering of this question. Okay. Number 2, describe and explain the steps you took to find and focus your paramecium. Walk me through it step by step. Okay, first I did this, then I did this. Talk about everything that you do. It's basically the steps I went over on how to use a microscope. Start here, find, do this, then do this. Okay, that's what I want you to walk through. Point form is fine. Okay, you don't need a big long explanation.
What the letter E, because it's a real image, you want us to make sure that it's vertically.
Yes, when you put the microscope slide, and that's what I said earlier, when you put the microscope slide on the stage, the letter E needs to be right side up. So I look at it, I put it under the microscope, then I put my eye on. Yeah? Okay, that way we know what it's doing to it. Okay, and then third one, why do we add water to a wet mount? Remember that cool demonstration I did when I turned it upside down and didn't fall off? Okay, might want to talk about some stuff we talked about in the last unit on that question. Okay, adding water to a wet mountain is not to keep the letter E alive, by the way. Okay, I've seen that answer before, so I'm just putting it out there that that's not right. Okay, cover slip. Okay, and remember, guys, part of this why isn't just make the cover slip stick. Like, I'm looking for why does it make the cover slip stick? Okay. All right, for the conclusion, restate your hypothesis, just copy and paste it. Okay, tell me, talking about question 1 here, probably a lot of question 1, okay, in your acceptance or rejecting of your hypothesis, okay, and then your 3 sources of error. I would say your 2 sources of error. I would say that a source of error could be inexperience. Probably most of you haven't used a microscope all that often in your life yet. Okay, and that could certainly be a source of error. It's not something that you can fix right now. Okay. All right, questions on what we're going to be doing? Okay, we have 40 minutes to look at 4 things under the microscope. Remember, you need to get a picture of each thing. Now, you can have one person in your group take the picture and then send it to each other. Okay, send it to your school emails. Okay, the big thing here is it has to end up in your school Google Drive for you to be able to use Google Drawings and put it in your lab report. Okay, so whoever takes the picture sends it to everybody's Isidore account. Okay, everyone follow on that? Okay, if you're the person who takes the picture, you could email it to yourself, or you can just do the put it in your Google Photos thing that I talked about yesterday during the podcast. Okay, either one will work. Okay, then just take it from your email and put it in your Google Drive where you can find it. All right, one good picture of each specimen is all that is required. All right, if you're having a lot of trouble, call me over and I'll come and help. Okay, we'll leave the Chromebooks in here. There's no reason to take them across really, because all you're doing is looking at stuff and taking pictures and you don't need them for that. Okay, all right, so we're going to the biology lab. The door is unlocked. Unless you think you can give yourself a shiner by smoking your eye on, no, I think we'll be okay. Yeah, don't run with scissors. Yeah.